Hello, my favorite Math 7 students. Today we're going to fill out the evaluating and writing algebraic expression notes. And our essential question today is, how do we evaluate expressions? So starting with some vocabulary that you need to be familiar with. A variable is a letter that represents a number. An algebraic expression is a statement with variables. And when you see the word substitute, substitute means to replace something in your problem. And when you see that word evaluate, I just mean perform the operations or do the problem. When you get those copied down, make sure that you also get the questions along the left-hand side. Remember that we can use those as flashcards to help us learn and remember the different vocabulary terms. Now, when you evaluate an expression, make sure that you follow the order of operations, which we discussed in Unit 1. I did write down the letters to help remind us, what are the order of operations. So in example 1, we've got some values here. The club is going to represent the number 8. The smiley face is going to represent the number -1, and the symbol that looks something like a flower is going to represent the number 3. So in question number 1, we see 6 written next to the club. When you see a number written next to some kind of variable or symbol, that's going to mean invisible multiplication. So for this problem, we're going to multiply 6 times whatever value the picture stands for. In this case, it stands for the number 8. So 6 times 8, which is 48. In the second example, we see smiley face plus the flower. So the smiley face has a value of -1, while the flower has a value of 3. So what we see represented by the symbols is really just the math problem -1 plus 3, which is 2. Lastly, we've got 3 things going on here. So the club has a value of 8. We're going to subtract the value of the flower, which is 3, and then we're going to add the value of the smiley face, which is -1. So following the order of operations, we're going to subtract 8 minus 3, which is 5. And notice I'm going to recopy down what's left of the problem. So 5 plus -1, which is just 4. So when we evaluated these 3 expressions, we got the answers of 48, 2, and 4. Now this is how you're going to typically see algebraic expressions using variables to represent your numbers. So in this particular problem, A is going to be standing in for the number 6, B will be representing the number -0.5, and C is going to represent the number -2. So evaluating our expressions, in the first one, 6, and then it's written right next to a set of parentheses. So that's invisible multiplication. 6 times the quantity, C minus 1. Well, up here, C really represents the number -2. So -2 minus 1. And following order of operations, I would do the parentheses first. -2 minus 1 is -3. So I'm going to recopy down the whole problem and just change the -2 minus 1 is going to become -3. So 6 times -3 is -18. When I evaluate this expression, given the values I highlighted, we get -18. Now for number 2, let's see, A divided by 1 minus C. Well, A has a value of A has a value of 6, so 6 divided by, and then 1 minus C, again, C is -2, so 1 minus the value of C, 1 minus -2. So I actually need to evaluate that first. 1 minus -2 needs to be looked at first. So I'm going to recopy down the problem. 6 divided by, and then 1 minus -2 is really the same thing as 1 plus a +2, or 3. 6 divided by 3 is 2. So evaluating that expression, I get 2. Lastly, c minus 13 divided by 5. Well, c has a value of -2, subtracting 13, and dividing by 5. So first we need to evaluate -2 minus 13. -2 minus 13 is -15, and that's still divided by 5. -15 divided by 5 is -3. So evaluating this expression, we get an answer of -3. And what I want you to really see here is that in all these problems, whatever the value of the variable was, I replace that in the problem. So for example, in number 3, instead of writing c minus 13, we substituted the value of -2 in for c. All right, so a couple things that we want to talk about. When you see an expression, we've already noticed that there's several ways to write a multiplication problem. So for example, you've seen me write 6.3. That means 6 times 3. If we have parentheses, 6 times 3 in parentheses, that again means multiplication. Sometimes you might even see both numbers in parentheses, that still means multiplication. And lastly, we'll see a lot of this, a number written next to a variable, which again we should assume means multiplication. As far as division goes, we are all used to seeing 6 divided by 3, but the way I would probably suggest to you to write it is more like a fraction. Fractions mean division. 6 divided by 3 or 6 divided by h. Of course, we also know the long division, but all of those representations you guys should recognize as being either multiplication or division. Now, in the box, we've got some words that represent addition, subtraction, multiplication, and division. You can think of these, I guess, as clue words when you are reading through story problems or when you need to write your own expression. So, for example, the words increase, add, deposit, those all suggest addition. Decrease, withdraw, fewer would suggest subtraction. Times, or how many times, multiply, product mean multiplication, and quotient, into, split, or split evenly all mean division. So using those terms, we could write our own expression. So for example, a temperature of T degrees increased by 5 degrees. So I see that word increased, which is a clue word for addition, T plus 5. For the next problem, 5 fewer cats than C cats. The word fewer suggests subtraction, so C minus 5. The product of 5 and n nickels suggests multiplication, 5 times n. And then lastly, a dinner bill of $D divided among 5 friends. So that one kind of says the word right in the problem. We're dividing. D divided by 5 would be that expression. So off on the left-hand side here, let's maybe write down an example problem. How about the product of 6 and G? So that's an example problem you can use as your note cards. Flip it over and check your answers based on what we have filled in so far. All right, well, that wraps it up. Example 4, you can try on your own, and we'll go over those examples in class on Thursday. Have a great day.